Hello and welcome, students. We're about to dive into an experiment that ties together the critical concepts we've been exploring about the nervous system and reflex responses. So far, we've delved into the general structure and function of the nervous system. We've learned that the nervous system is responsible for detecting changes in our environment, processing this information, and orchestrating responses to ensure our bodies maintain homeostasis. We've also discussed the concept of a reflex response, a rapid and involuntary reaction to a stimulus, which happens without conscious thought to protect our bodies from harm. Today, we'll be connecting this knowledge to a new and practical experiment. We will investigate how caffeine, a stimulant, affects reaction times. As you know, reaction time is a measure of how quickly our nervous system responds to a stimulus. By examining the influence of caffeine, we're directly observing the nervous system in action and understanding how external substances can modulate its performance. We have two methods to measure this: using a simple measuring stick or employing a more efficient computer-based system. Both approaches will give us valuable insights into the speed and efficiency of reflex responses under the influence of caffeine. Before outlining the practical, let's take a moment to consider its importance. First, this practical allows you to observe how a commonly consumed substance, caffeine, affects your body's nervous system. Reaction time is a crucial aspect of how we interact with the world, influencing activities ranging from driving to playing sports. Understanding the physiological effects of substances like caffeine on reaction time can shed light on its broader impacts on daily functions and inform decisions about its consumption. Second, conducting this experiment requires precise measurement, careful observation, and systematic data recording, all of which are vital skills in scientific research. Finally, this experiment ties into the broader module on homeostasis and response by providing insight into how external substances influence internal bodily functions. Caffeine affects neurotransmitter release and neuronal firing rates, offering a real-world example of how external factors can disrupt or enhance the body's natural state. Conducting this experiment provides a concrete way to see these theoretical concepts in action. Let's start with the measuring stick method to test reaction time. First, have the individual whose reaction time is being tested sit with their arm resting on the edge of a table. This position will stabilize their arm and prevent any extraneous movement that could influence the results. The person assisting will hold a ruler vertically between the thumb and forefinger of the test subject at the 0 centimeter mark. The subject should not be touching the ruler, but they should close their grip to catch it as quickly as possible once it has been dropped. This setup is crucial for accurate measurement. Now it is time to conduct the initial test. At an unexpected moment, the assistant will release the ruler without warning. The test subject should attempt to catch it as quickly as possible. The reaction time is determined by the mark on the ruler where it is caught. The value above the thumb indicates how far the ruler has fallen, with larger numbers meaning a slower reaction time. This test should be repeated several times to ensure consistency. Calculate an average distance by summing all the values and dividing by the number of trials. The third stage is to introduce caffeine. The test subject should consume a caffeinated drink, such as cola. It is important that this is their first caffeine intake of the day to keep the variable isolated. Allow a 5-minute wait time for the caffeine to start having an effect on their body. After the wait time, conduct the ruler drop test again using the same process as before. Ensure that the same individual catches the ruler to maintain consistency. Record the results in your lab book, just as you did before. An alternative method to this practical involves using a computer to test reaction time. This process is automated to remove the effect of human error, increasing precision. It also removes potential bias from physical or visual cues from a human doing the test. At a computer, the test subject will click a mouse in response to a visual stimulus, such as a color change on the screen. This can even be set up to record precise reaction times in milliseconds. Then have the subject perform the test several times both before and after consuming caffeine. The software will provide a more accurate and detailed record of their reaction times without the potential for human error. Whether using the ruler or computer method, it's essential to control for other variables such as the individual's caffeine intake prior to the test and their state of alertness to ensure fairness. Let's recap some of the key steps of the experiment and their importance. First, let's consider the importance of the arm positioning. Having the arm resting on a table edge restricts arm movement, ensuring that only the fingers move. This control is crucial for standardizing the test conditions and ensuring that differences in reaction time are not due to extraneous arm movements. Second, let's think about the ruler setup. Holding the 0 centimeter mark of the ruler between the thumb and forefinger of the test subject standardizes the starting position. Dropping the ruler without warning tests the subject's true reaction time, minimizing the effects of anticipation or prediction. Third, why did we measure how far the ruler had fallen? Well, noting the point on the ruler where it is caught directly correlates to reaction time. A higher catch point means a longer time to react. This provides a quantifiable measure to compare pre and post caffeine reaction times effectively. Fourth, why did we repeat the experiment? Repeating the test several times and calculating the mean value helps to account for variability and improve the reliability of the results. And finally, how did we control the variables in this experiment? First, we left 5 minutes after consuming a caffeinated drink to ensure the caffeine is absorbed into the bloodstream. We also controlled variables such as the same person catching the ruler and their caffeine intake. We made sure they had none before the first test. This ensured that any observed differences in reaction time can be attributed to caffeine's effect. Now let's analyze our results step by step. First, recording the reaction times. For both pre-caffeine and post-caffeine tests, record the distance at which the ruler was caught or the time taken to react. Ensure you have multiple measurements to calculate an average. Second, we calculate the average distance or reaction time for each condition, pre and post-caffeine. For example, if the distance the ruler fell before caffeine were recorded as 5 centimeters, 4 centimeters, and 7 centimeters, the mean would be these 3 results summed together and then divided by 3, which gives us 5.33 centimeters. Now we can compare the average reaction times or distances before and after caffeine intake. A decrease in the average distance, or reaction time post-caffeine, indicates an improvement in reaction time due to caffeine. As we can see from our results, the average distance after caffeine was lower than the average distance before caffeine. This tells us that consuming caffeine increased reaction times, assuming that all of other factors were held constant. We can now create a graphical representation. The x-axis represents the condition, before versus after caffeine, and the y-axis represents the reaction time. Plot a graph with 2 bars, one for the average pre-caffeine reaction time and one for the post-caffeine reaction time. This visual comparison can help illustrate the effect of caffeine clearly. Now we can interpret the results to discuss how caffeine affects reaction time. If the reaction time decreased after caffeine, it suggests that caffeine speeds up reaction time. Consider discussing the biological mechanism behind this, such as the role of neurotransmitters. Finally, we can identify and discuss any outliers or unusual results. Potential experimental errors like inconsistent ruler dropping or incorrect measurements could account for anomalies. Evaluate the experiment's limitations and suggest improvements for future tests. By following these steps, we can systematically analyze the effect of caffeine on reaction time and discuss its implications within the context of human physiology and homeostasis. In today's lesson, we conducted a practical experiment to measure the effect of caffeine on reaction times. The key steps of this practical were setting up, taking the initial measurement before caffeine, participants consuming caffeine, measuring the reaction time after caffeine consumption, and finally, recording and analyzing the data. We learned about the concept of reaction time and factors that can influence it, and the role of the central nervous system in processing stimuli and responding quickly. We also learned about the effects of caffeine on the body. Our key takeaways for future practicals are to ensure accurate timing and consistent testing conditions to gather reliable data, and to understand the importance of control groups and baseline measurements in experimental design. Great work today. See you next lesson.